Okay, then we will start. Today, the class is about uh, basics of remote sensing and digital image processing. So, the slide is visible to all of you. Hello.
Yes, sir.
Yes, sir, it's really visible.
Okay, okay. So, before starting the digital image processing, we will discuss about different remote sensing basics and remote sensing technology, how these satellites data are arranged, and what is the information besides this satellite images. So, in the remote sensing techniques, there are some energy resources illuminations and radiations of the atmosphere is also included. Then interaction with the target and recording of energy by the sensor, transmission, reception, and processing. So these are all process going through the remote sensing techniques and going through by different satellite sensors. So after that, we get the output result in the satellite images. After that, we interpretation and analysis was going there. Then some applications are coming into picture. Then different platforms. So remote in the remote sensing technology, we get different platforms. So we get the aerial photograph in the low elevations. Then space-borne platform like satellite image get the different satellite images as per their requirements. So these are some platform. Then these are the arrangement of different satellites in different orbit, like geostationary orbits, polar orbits. So in the Earth observation, we just discussing about the only polar orbits. So in the polar orbits, they are the low Earth orbits, and they are useful for different geo geographical features of different areas. So these are also discussed before, the energy sources and radiations of the atmospheres, then interaction with targets, recording of energy, transmission, reception, and processing. So these remote sensing based images are going through these type of processes. Then interpretation and analysis and application. So advantages of remote sensing technology is about the synoptic view, and it is coverage a large view as compared to other aerial photography. Then it is also globally coverage for different areas. That's why it is very much useful for all over the world. Then repeatability is also very much important because we can find the images before the earthquake and after the earthquake, along with we can also found some data before the flood and after the flood, so we can analyze and we can draw a line about the coverage area. Then multispectral set scanner sensors, these are also useful for different features identifications in different wavelengths. Suppose for urban mapping, we use different spectrum of wavelength. Then for mangrove and forest classifications, we we need some infrared region of the spectrum. So different spectrums and different spectral bands are useful for different applications, like hyperspectral image, which needs more spectrum, like 200 to 250 spectrums are there for mineral explorations. Then multi-resolution data for geological structure analysis, we use uh, low satellite resolution data, and for urban mapping we use high resolution data. So near real time for climatic informations, we get the near real time data. Then systematic data collection. So all these data are collected in there's a unique ID, and row and path informations are there. So this is also important for identification of the location of the grid of these systems. Sometimes the otherwise inaccessible areas are also accessible with the help of some satellite data. So these are the advantages of this remote sensing technology. And another thing is in the processing of this remote sensing, it is very fast, and micro remote sensing that is newly added in the recent 10 to 15 years, so that it can penetrate the cloud, and we can get the cloud free data, which is very much useful for earthquake mapping and flood inundation area mapping. Then update revision of the existing map is very inexpensive and faster. Then color composite ensure the details of the area. Then natural disaster studies and other various studies are useful for this remote sensing technology. And overall, it is also cost effective. So likewise, these are some advantages, and the earlier photograph hot air balloon. So these are already discussed. Now we will discuss about some images and digital images. So generally, what is the image? So we call that is image and photograph. So image is just pictorial representation of a object or scene. So generally, image is based on the object or scene. So for in this remote sensing from scenario, we use the images of the geographical locations. So basically for observation of different arts or from pictures. So there are two type of form of images are there, that is analog and the digital. So in the analog image produced by the photographic sensor on paper based media or transparent media, so it is basically the hard copy of the images, and it varies in the scene characteristics are represented as variation in the brightness. So different gray shades are there. Then object reflect more energy appear brighter on the image, and object reflecting less energy appear. So the object which is reflecting more energy, it gets the brighter than the.
आवाज नहीं आ रही है सर.
Is it audible now? हेलो, अभी आ रहा है?
Yes, sir, audible, sir.
ओके. तो जब जो भी चीज़ का जो एनर्जी लेवल हाई होता है इन द रिफ्लेक्टेड फीचर्स में, तो उसमें हम ब्राइट इमेजेस आता है. देन सेम इज ऑल्सो अप्लाई टू द डिजिटल इमेज इन द सैटेलाइट सेंसर्स. जो रिफ्लेक्ट ज़्यादा होता है उसका ब्राइटनेस ज़्यादा आ जाता है, और जो ज़्यादा एब्जॉर्ब करता है जो रेडिएशंस लाइक वाटर बॉडीज एंड ग्रीन वेजिटेबल ग्रीन प्लांट्स, सो इट्स लुक्स लाइक द डार्क टोन. तो उसके हिसाब से हम क्लासिफिकेशंस कर सकते हैं डिफरेंट डिफरेंट फीचर्स का. तो जैसे आ गया आपका सैंड आ गया, ड्राई लैंड आ गया, देन बिल्डिंग्स. तो these are the dry, these are this appears the high brightness, and it's reflected high electromagnetic radiations. So based on these, we can identify these locations based on the associations and the localities of these areas. तो तो डिजिटल इमेज क्या है कि कंपोज ऑफ टिनी इक्वल साइज स्क्वायर पिक्चर एलिमेंट्स. सो जनरली हम जब सैटेलाइट डाटा यूज करते हैं तो इसमें क्या होता है कि बेसिक यूनिट जो है इट इज कॉल्ड एज पिक्सेल. So each pixel is a square size. It cannot be a rectangular or as circle or elliptical or any diagonal shape. It is a um, square size unit pixel is there. So each unique pixel में different information से depend upon the satellite data. Some have DN value like digital number values. So according to the beat of the satellite, for 2 bit that is 1 to 2 number, and for 4 bit that sorry 8 bits it is 255 numbers, 0 to 255 number of DN values are there. Then for elevation data it is height information say are there, means in sea level heights. So these are some of the informations, pixel level informations, and it is arranged in two-dimensional matrix format. So XY coordinate system is there. So these are arranged in row and column. So each pixel is associated with number known as digital number, and brightness value or gray level which is recorded of variations in radiant energy. So which suppose some objects get highly reflected, then the distant number is very high, and which is absorbed more, then its distant number is very less and equivalent to the black in the gray level images. So this is the example of the gray level images. So this is the satellite image of different pixel value. So the maximum is the white color, that is 255. I think it is also shown in the pixel 255, and minimum is the 0, which is signifies the black color of this pixel. So minimum 0 to 255 means it is arranged in a, it is like a 8-bit computer, 8-bit satellite image, which is 2 to the power 8, which is the result of 256. So 256 is arranged in, from 0 to 255. So this is the result. So they are arranged from 0 to 255 weights. So some are 238, some are 136. So which are more reflectance value, so it is nearer to 255, which are less reflectance value, so it is nearer to 0, that is 1785, 17. So these are nearer to the black, so uh, it signifies the high absorbance of these radiances. So here the pixel value, the magnitude of the electromagnetic energy captured in digital images. So generally, these pixel values cannot be in a negative way. Suppose a negative value like minus 2.25, minus 23. So these are seen in the grid values. Suppose in the elevation information, some coastal areas show some negative value like minus 10, minus 20, minus 12. So these are the negative values based on the elevations. But in satellite image of different observation satellites like LIS-3, LIS-4, then other satellites Landsat 8, Landsat 7. So these are all positive digital numbers are there. So it is starting from 0, then it will be 256 or 1024, This way, these are arranged. Then pixel is a short abbreviation of picture elements and it is unit of digital image and cell are sensed one after another along with lines. In the sensor, each cell is associated with pixel. It's also discussed. Each pixel is characterized by some single value of radiation, that is a reflectance, and it is converted by the photoelectric effect into electrons. So this is the final image, and these are all pixel based. So in the digital image processing, we use this information to analyze all this satellite data. So this is the basic units. We can change different uh, image classification techniques are there. Based on these values, we can use these images for different analysis. So how these values are determined? So that is called various bits are there, like a 1 bit image, it is exponential of 2. So every bit is exponential of 2, exponent of 2. That is 1 bit image, it is equal to 2 exponent 1 is equal to 2. So it color level is 0 to 1. So it is as for 8-bit images to the power 8, then 256. So it is arranged in 0 to 255. So this way, generally, we so see the satellite images 8-bit images, and some images have 16-bit images. So between these 8-bit and 16 bits, we can found all these satellite images. So in our previous satellite image, it is 8-bit images, so it's shown the brightness value from 0 to 255. The maximum number of brightness level available depends on the number of bits used in the representing energy recorded. Thus, if a sensor used 8-bit to record the data, then it will be the 256 digital value. So likewise. So this is also called as the radiometric resolution of the satellite. So depend upon the satellite variations, we can use different radiometric resolutions are there. Then another thing is the false color image. How this false color image are created? So nowadays we uses most of the time false color image. जो false color images आता है, तो it is not a true color image जो हमको दिखाई देता है ट्रू कलर इमेज में, वो फॉल्स कलर इमेज में डिफरेंट आ जाता है. तो डिफरेंस क्या है कि हमको इसका ग्रीन वेजिटेशन और फॉरेस्ट एरियाज आर सोन इन रेड कलर. सो इसमें फिल्टर यूज होता है, दैट इज green channel is converted to the blue channel. So green wavelength is converted to the blue, then red is converted to the green, then near infrared converted to the red. So the blue, green, red are arranged, then the final product is the infrared false color composite. So this is the final false color composite. So basically it is useful for vegetation index mapping, then forest classifications, and different water body extraction of the water bodies. So it is very distinctive about the water bodies and other vegetations. So that's why it is very much useful is compared to the true color composite satellite images. The Google Earth image, that is a true color composite images, but list 4 satellite image which are from Indian satellite. These are all false color satellite images. Then multispectral image. So if more than one spectral bands are used in the satellite, images, then it is called the multispectral image. So for the extraction of some color images or for the uses of the different application, we use the color image. So sometimes it is not possible to extract some of the area with a black and white image. That's why we use multicolor satellite image, that is multispectral image. So generally we use 3 to 4 bands, and each band has different spectral wavelength. So in this picture, that is band 1, it is a blue band, that is 0.45 into 0.52 micrometer, that is the wavelength of this band. Then band 2, 0.52 to 0.59 micrometer. 1 micrometer is 10 over minus 8 meter. So this is a very narrow wavelength is there. Then band 3, 0.6 to 0.68. Then band 4, 0.7 to 0.86. So here the band 4 is the infrared band. Then band 3 is the red band, and band 2 is the green band. So likewise, all the in bands are there. So for this satellite image, each band has some digital number which are shown in the upper side of this image. So different values are there for different bands of the satellite images. So for this particular area of same area, the reflectance value is different for different bands, because its reflectance resultant is different for band 1 and band 2 or band 3. Some spectral bands absorbs more in water bodies, and another is reflectance more. So that's why the resultant is different. So after combining all these band, we get the color images. Then likewise, these are some resolution types. So these are there are 4 resolutions are there. That is spatial resolution, spectral resolution, temporal resolution, radiometric resolution. Sometimes it is also asked in short mark what is the different resolution of the satellite. So spatial means just discuss about the pixel dimension. Suppose the dimension of the pixel is 5 meter into 5 meter, then the spatial resolution of this satellite is 5 meter. And for list for satellite image, it is 5.8 meter resolution. So for the spatial resolution of the list for satellite image, it is 5.8 meter. For list 3 image, it is 23.5 meter. And likewise, different resolution, like for sentinel 2 data, the spatial resolution is 10 meter. That means each pixel dimension is 10 meter into 10 meter. Then spectral resolution define that how much spectral bands are there in a satellite images. Suppose for list 4, there are 4 satellite sensors, spectral bands are there, then the spectral resolution is 4. So likewise, mm, 11 spectral bands are there in the Sentinel data, though spectral resolution of this Sentinel-2 data is 11. So likewise, the different satellite data have different spectral bands and different. Another thing is hyperspectral images, which has the more spectral bands, like more than 200 spectral bands are there. That's why it is called as hyperspectral bands, hyperspectral images. So it has high spectral resolutions because of different spectral bands arranged in a very narrow bandwidth. That's why it is very much useful for different mineral explorations and other applications. Then temporal resolution. Temporal resolution is related to the time. So it is time between the observations. So first observation to second observation, how much time is taken. For suppose, so one satellite data covers same area after 24 hour, then the temporary resolution is 24 hour. Then radiometric resolution just discussed about previously, that is 8-bit images means it is 256 different colors from 0 to 255. That is the radiometric resolution. The radiometric resolutions, how the gray value are arranged from 0 to 255 or 0 to 1024. So different color variations are there. So 1 bit radiometric resolution data, it means only black and white. Two colors are there. For two radiometric resolution means 2 to the power 2, 2 to the power 2, that is 4 color. So first is black, last is white, then in between the gray value are present. So likewise 255 gray level shadings are there in the 8-bit radiometric resolution data. So if the radiometric resolution is very high, then color variations are very high. So it is very much useful for different identification of objects. So for details identification, we need a high resolution of the high spatial resolution data with high spectral resolution with high radiometric resolutions. So temporal resolution is not much useful sometimes, because it is temporal resolution very much useful for uh, some flooding information data or earthquake data. But urban mapping or forest classifications, we need some high spectral resolution and radiometric resolution data. These are some images: 10-meter resolutions, 30-meter, 80-meter. So high spatial resolutions data give the more details as compared to low spatial resolution data. Then sometimes it is also asked in the exam that instantaneous field of view. What is the instantaneous field of view? So it is angular cone of visibility of the sensor. So there is the A is the IFOV. So it covers the area of the bead, which determines the area seen from a given altitude at a given time. So we can calculate the IF, IFOV, that is area view in IFOV into altitude. If the altitude is known and the area is known, then we can get the angular results. So these are some spectral bands arrangement in the black and white images and multispectral images. So sometimes some satellite images uses different spectral bands of different bandwidth. So this is one of the lensed world view data. So it is useful for some bands are taken in this area, then this area. So some gaps are there. So based on the applications and based of the different sensor uh, absorbers capacity, so the specific bandwidths are chosen for the different satellite images, because other bandwidth are not useful for other different applications. Then spectral hyperspectral sensors, so a lot of spectral bands are used in this hyperspectral sensor. So one of the example is the Everest data. The more than 200 spectral bands are attached to these satellite images, and it is not free of cost. It is a very costly satellite image. So these are some multispectral scanner. And different bands are there. Then thematic mappers, then enhanced thematic mapper, different bands are used for application. So this is not useful for this in this gap, that is not useful for different applications. Then what is also discussed, time between the observation, then radiometric resolution also 6 bit 64, then 8 bit 256. So this is the result of the images which are 1 bit. So it is the 1 bit images which shows only black and white, and there is no other colors are there. And for 2 bit image, it is 4 colors are there, black and white, and some gray values are there in between the black and white. Then 4 bits, then 8 bits. So clarity is more if the bit of these images are high. So minimum 8 bit system of satellite image is very much useful. Then if 10 bit 12 bit is available, then it's very good. So minimum 8 bit images is required for identification of different features. So previously not available, so it is very much difficult to identify the features. So these are the example of the Cartosat 1 and Cartosat 2 satellite spatial resolution, that is 2.5 meter resolution, that is Cartosat 2 it is 0.8 meter resolution. Then sensor type is panchromatic, and Cartosat 2 also panchromatic means there is a black and white satellite image. So the one band is there, that is it is called as panchromatic. So if the single band is there, then there is no color images is available. So minimum 3 images are required for the color image. Then the swath, what is the total length of the satellite image, and revisit time 5 days and 4 days. These are the temporary resolution of the Cartosat 1 and Cartosat 2. Or beats and or altitude is 618, 630. So this is not important. Then different type of sensors are there. How many sensors are there? So sensors are divided into active sensor, then passive sensor. Then passive sensor is again divided into scanning and non-scanning. Then non-scanning is divided into the non-imaging, like the microwave radiometer, magnetic sensor, gravitymeter, Fourier spectrometers, spectrometer, gravitymeter. These are give the result in the graph form, so not in the image form. Spectrometer generally used for the hyperspectral image analysis. So which particle give the different wave spectral bands are there. So different spectral libraries are formed. So this is a non-imaging sensor like gravitymeter and Fourier spectrometers, magnetosensors. Then non-scanning, one of the imaging is camera, general camera, monochrome, natural color infrared, others. So these are a general camera which is imaging but non-scanning. It is not scan the different objects. Then passive scanning images are image plane scanning, the TV camera, solid scanner. Then objective plane scanner is optical mechanical scanner, microwave radiometer. So these are some example of the scanning imaging. Then active sensor is non-scanning and scanning. So for non-scanning, non-imaging, that is micro radiometer, micro altimeter, laser water depth meter, laser distance meter. So this gives the information about the different objects in the format of depth or any spectral reflectance. So that is non-imaging uh, sensors. Then scanning, which is scanning and imaging, is object plane scanning, real aperture radar, and synthetic aperture radar. These are satellite image. All these are satellite image. Then image plane scanning, that is passive phased array radar. So these are some radar images which are scanning and imaging, and it is active means active and passive. The difference is it has all illumination and it has own source of energy. It cannot be depending upon different other sources like sunlight, but in passive it is depending upon the sunlight for photography. Radar has their own source of wavelength, so it can passes through the some object, then it reflect back, then it get the information. So it does not require any sunlight or other sources of lights. That's why it is an active sensor, and which needs the other sources of lights or sources of energy, then it is called as passive sensor. So all of the Landsat 8 and Earth observation satellites like LIS 3, LIS 4, Sentinel 2, all they are passive sensor satellites, and some micro sensor radar data which are useful for earthquake mapping and flood analysis, like Sentinel 1A, that is a microwave data, that is also a active sensor. So active remote sensing, that is instrument pulse needs power to operate. So this is the active sensor. Then the passive sensor, it needs the sunlight. Then it's reflect back the brightness. Then it is collected all this brightness value. Then it is give the picture of these objects. But in the active sensor, it sends the pulses to the object. Then it reflect back. Then it collected. Then it shows the different graphs form or different image form. So these are the active sensor like radar and SAR, synthetic aperture radar, that is form of the SAR, laser fluorescence, LIDAR data, so which is useful for the height information observations. Then the passive sensors. The sun's energy is either reflected or absorbed and then re-emitted. So remote sensing system which measures energy that is naturally available are called passive sensors. So most of the time, some of the time, that is the difference between the active sensor and passive sensor was also asked previously. So some short questions are also asked. So passive sensor can also be used for detect energy when the naturally occurring energy is available. For all reflected energy, this can also be take place during the time the sun is illuminating the earth. There is no reflected energy available from the sun at night. So during the night, there is a no observation is possible. So it is only working in the daytime. Then the active sensor provide their own source of illumination, and the sensor emits the radiation which is directed towards the target. Targets mean the Earth's some of the Earth features. And then the radiation reflected back. This targeted, detected, and measured by the sensor. The advantages for the active sensor includes the ability to obtain measurement anytime, regardless of the time of day or season. So it is very much useful whether it is day or whether it is a night time. And most of the time, very precise observations are also measure. For example, some buildings movement for last 10 years, if there is a 1 meter or 10 meter deviate from its base point, then it is also detected with the help of this microwave or radar data. And the active sensor can be used for examining the wavelengths that are not sufficiently provided by the sun, such as microwave, and better control the way to target. So some of the wavelengths which are not useful with the help of the sun's EMR data, then it is useful for the active sensor data. However, the active system requires the generation of fairly large amount of energy. So the basic difference between this is the active sensor satellite images are very a large number of informations are there, and the image volume is very large. So for same reason, if the passive sensor satellite image occupies 1 GB data, then this active sensor data occupies 100 to 150 GB data. So the processing is very uh, complicated, and it is needs very high level of hardware and software. So this is some of the difference, and best example is the synthetic aperture radar, which is a radar data. So this is the images which shows the one of the features of the reset satellite image. Then different multispectral bands like Landsat Age and Landsat 8 image. So different bands are there. There are 7 bands which are useful for the different applications. So as per our applications, as per our uh, different work, we can join all these bands like blue green bands. Then we can more composite this image, then we get the output. So in this satellite image, there are some across track scanning system are there. Then along track scanning system of the satellite images are there. Then across track scanning is one of the important scanning system that is using rotating oscillating mirror is there. So system scan the terrain along scan line that are right angle to the flight line. So it is the right angle to the flight line. So it is scanning left right. The scanning direction is given in this area. So the across track scanning. So it is not along track. Some movements of the sensor with a 90-degree angle of this scanning system. So these data are collected within the arc below the system, and the incoming energy is separated into several spectral components that are sensed independently. So this is the scanning system. Then different instruments are there. Then the spectroscopes, detector, folding mirror, scan mirror, instantaneous field of view, flight direction. So the direction of the flight is 90 degree to the scanning system of this sensor. So that's why it is called as across scanning system, across track scanning system. So some of the examples are multispectral scanner, lighting, MSS, thematic mapper of Landsat data. So Landsat data are across track scanning system, and AVA HRR of NOAA, the example of optical mechanical scanner. So these are some example of the across track scanning system. Then the along track scanning system. So when the flight is moving along one direction, then the tracking system is also in the same track. So as with the across track system, the along track push broom or scanners records multispectral image data along a swath beneath an aircraft. So same direction is scanning. So also is similar use of forward motion of the satellite to build up the image by recording successive scan line. They are oriented at right angle to the flight direction. However, there are a distinct difference between along track and across track is the manner in which each scan is recorded. In along track scanning, there is no scanning mirror is there. Instead, a linear array of detector is there to scan in the direction parallel to the flight line. Array normally consists of numerous charge coupled devices, that is CCD positions and end-to-end. So these are some scanning system are there. So advantages of along track scanning: a linear array provide the opportunity to each detector to have a longer dwell time or residence time, or which measure the energy from its ground transition cells, and also enable a much stronger signal to be recorded and greater range in the level of signal, leads to better spatial and radiometric resolutions. So these are some advantages. So you can just go through it. Then along track, across track, and their advantages all are important for the theory exam. Then after that, what is the digital image processing? So most of the time, before going to the GIS applications, we have to process all these satellite images using different parameters. So this is the processing which is useful. After that, we can use the satellite data. So before that, we have to go through the digital image processing system. So what is the digital image processing? So digital image processing focuses on two major tasks, that is improvement of picture information for human interpretation. So for our applications, we need some clear satellite image. So some of the time the image is distorted for different reasons. That's why we have to enhance this satellite image to useful for particular applications. So that is the improvement of the images are required. Then second is the processing of image data for storage, transmissions, and representation of autonomous machine perceptions. So some of the data of the images are different format. So it is also taking the lot of memory, and it is not suitable for different applications. So to useful for this different application, the memory storage also decreases, and different dimension and different dimension of the satellite image are corrected. The some argument about where the image processing ends and fields such as image analysis and computer vision start. So before that, a lot of different applications are there for image processing. For in 1980s to today's, the useful digital image processing techniques has explored, and more technologies are there nowadays. Uh, Data science and some artificial intelligence also useful for this processing. Then now used for all kind of tasks in all kind of areas. That is image enhancement, restoration, artistic effect, medical visualizations, industrial inspections, law enforcement. So a lot of applications are useful. So it is not only useful for the remote sensing and GIS technology, but in the different applications like in the medical field and industrial areas, digital image processing are very much useful. So this is the one of the example why digital image processing improve the quality. This is the X-ray image of some human body. So after the enhancement, it's clearly visible all the different skeletal and other features. So likewise, this is the difference between the before enhancing the image and after enhancing the image. So the last the satellite image, which is some distorted image, then after enhancing the image it is clearly visible. So that is the one of the important part for the enhancement of the satellite image. We cannot use the raw data all the time. So the key stages in digital image processing are there, that is problem domain. What is the problem of this satellite image? Then image acquisition, then we get the image. Then after that, the image enhancement techniques are there, and then we get the image restoration techniques are there. We get through the restoration technique. Then morphological processing, then segmentations, then object recognition, then representation and descriptions, then image compression, then color image processing. So these are the all processing, and then the different stages of the digital image processing. So we to go one by one. Then the image acquisition. First is the image acquisition. The image are acquired with the help of reflecting value of the sunlight of different electromagnetic radiations. So this is the basic image which are getting. Then we have to observe what is the problem with these images. So this is the image acquisition from the satellite uh, uh, sensor. Then the image enhancement. So after getting the image, then we have to find out what is the problem with the satellite image. Then we found some blurring effect are there. So we get the enhancement technique. Then we get the enhancement images, which is the result from this enhancement of these images. Then after that we have to find out what is the restoration technique. Then in the restoration, suppose in the Lancet 7, some of the Lancet 7 and images are, some are scan line error are there. So this is the scan line error. So it is a defect in the sensor itself. So to overcome all these errors, so we have to go through different filters, different application in the, some of the tools are available in the Redas and NV software. So in this software, we can eliminate all this scan line error. Finally, the resultant images, scan line error free images found. So after getting all this free of scan line error, some informations are also missing. So it can be calculated as the average mean of the nearest pixel to get the information. So it also gets some loose of the information after getting this type of images, but it is not it's a big issue, so we can use it for our different applications. Then that is the morphological processing. So in the morphological processing, the edge part is very much important. That is the water bodies and the surface areas. So then can morphologically different features are there. So we can get the morphological information by differentiating the different edges. So this is the result of this satellite image. Then the segmentation part. So in the segmentation part, there are different uh, settlements are there, different uh, pictures are there. So we can get the segmentation informations based on their reflectance and their different color value. So we can get the different segmentation based on this the reflectance value of this satellite image. So it is segmented based on the previous data, that is what is the settlement area, what is the vegetations area, what is the uh, road networks. So these are all different segments are calculated. Then object recognition. So particular area, some objects are recognized. Suppose this building says this house is recognized. So based on this house, we can apply this techniques for multiple houses. So at a time, these multiple features are detected, and this is recognized as the settlement area. Then representation and descriptions. So after that, suppose it is a raster data, and then we get the information about a polygon. So in the raster data, the polygon features are like that. As this is a pixel value based information, then we convert it into vector data. So the smoothness gradually increases, and it is clearly visible in the smoothness with some smooth features. That is the different representations and descriptions. So generally, when we describe the classification in the supervised and unsupervised, then this type of polygons are arises. Then we convert it into different vector data. Then the different smoothness techniques are there. Then we can get the smooth polygon. Then image compression techniques are there to compress different uh, satellite image, which can be saved as a JPG format or .img format, .rs format, tipped format. So different format have different memory allocations. So we have to compress this satellite image for our useful purpose and for easily handle the satellite data. Then color image processing, then different bands are joined to get the different color. So we can get different satellite image like false color images, then composite images, and that is true color images. So as per our requirement, we can get this data based on the primary different data. So this is previously also discussed about this gray level data. This is a pixel and this digital number. So this is also the false color composite image, that is green is converted to blue, then red converted to green, then infrared red. So why we use the false color satellite image? So the healthy vegetation show the shade of red because vegetation generally absorbs most of the green and red energy and reflect half of the incident infrared energy. So it reflects infrared energy and it absorbs more green and red energy. That's why urban areas reflect equal amount of nearest content and red green, and therefore they appear as still gray. So these are due to this we get the infrared images to get the vegetation index, sorry, vegetation areas. The red color which are given in these areas are all vegetation areas and forest areas. So it clearly distinguishes with other objects. But also we can get the true color composite. But if we get the true color composite for the vegetations, but other areas are not considered as a true color because it gets a different color. So instead of the infrared to red gun, we can use the red to red, infrared to green, and green to blue. That's why we get the true color composite. Then the electromagnetic radiation. So the first requirement for the remote sensing is to have energy sources, and that is the EMR radiation, the fundamental properties, and behave predictable way to according to the basics of wave theory, where the the two characteristics of EM radiation is the wavelength and frequency. So speed of light is multiply of the wavelength and frequency. That's why the higher the wavelength, lower the frequency, and lower the higher the frequency, lower is the uh, wavelength. So it is inversely proportional, but wavelength is inversely proportional to frequency. So in the infrared optical, that is blue, green, red, have low wavelength and high frequency, and the radio wave high wavelength and low frequency. So different applications are there based on the different frequency and different wavelength of the data. So it is shown in this picture. Then image fusion technique is also very much useful for nowadays. That is suppose I have some panchromatic image of 5.8 meter. Then I have some list 3 image of 23 meter. So one is very high resolution panchromatic data, and another is very low resolution color image. So I want a color image having color code and the high resolution image. So that is the technique called fusion technique. We can get the high resolution satellite image with color informations. So in the fusion technique, we get the color image with high resolution data. So here the list 3 image, which has the 23 meter low resolution data, and it is a panchromatic, that is a black and white image, which has 5.8 meter, that is high resolution satellite image. So if I get, yeah, if I want to get the color with high resolution, then we have to go through the fusion technique, that is finally list 3 merge image is there. But in this technique we have to get the same area data so that we get the image correctly, otherwise it's get the false area. Then in saturation, hue and intensity is also mm, cover give a different role to the satellite image. So hue is generally is the red, green, yellow, orange, and purple. It is measured in color wheel from 0 to 360 degrees. So totally different colors of 360 degree is called as the hue. Then the saturation is the color's purity or how intense the hue is. Saturation is measured as the distance from the achromatic line with graving. So this is the triangle which shows the different saturations of the color. Then the intensity is the color's darkness or bright lightness. So this is the bar which is showing the different darkness to the brightness. So this is the intensity. So based on the hue, saturation, intensity, we can get the different satellites um, image object. We can get the different specific identification of the object. So here is the opposite of the red is the cyan, opposite of the blue is the yellow, then opposite of the green is the magenta. This is the color combination of this area. Then this is the panchromatic image. Uh, then it is the list 3 satellite image of different features are there. Then what is the histogram? Histograms are the basics for numerous spatial domain processing techniques. Histogram manipulations can be used effectively for image enhancement, and histogram can also be used for provide useful image statistics. Information derived from histograms are also quite useful in other image processing applications such as image compression and segmentation. So this is the histogram image of different applications. So the frequency distribution is a bar graph that display how often observe the value within the certain interval classes. So basically in the satellite image, the frequency distribution of the different pixel values are classified in the histogram form. One can specify the different classes of equal width that are used in the histogram. The relative proportion of the data that falls in each class is represented by the height of the each bar. For example, the histogram shows the frequency distribution of different 10 or 15 classes of dataset. The spread of points around the mean value is another characteristic of the displayed histogram frequency distribution. The variation and standard deviation of the black frequency distribution are also greater than those of the red frequency distribution. So in the black mm, areas, the black line, there is larger frequency distribution as compared to the red frequency distribution. So some of the example is that this is the satellite image. So in the graph, it is the frequency in the y-axis and the x-axis, that is the dn value. So we have already gone through the dn value. So when the brightness is large, then the dn value is also very large. When the brightness is low or nearer to the black, then the dn value is low. So here is the frequency of the difference gray level, where the 50 to 70 of the DN value is very large in this area, means the black color is very much dominant in these areas. Then 100 to 170 or 180, that is the mid gray value is present. Then very less number of uh, brightness level is present. That's why it is 180 to 200. So 200 to 250 is absent. That means the highest brightness value of this satellite image is not present. So basically, it is distributed from nearer to black and middle of the black. So the DN value distribution is not equally distributed. So it is concentrated in the middle of the DN value. So if a lot of the white patches are there, then the DN value gradually go through this area 200 to 250. So this is the one of the distribution of the DN value in the satellite image. So which part is more dominant, which part is less dominant. So this is also shown in the DN graph format or frequency distributions. So then I expresses DN value and displays represented, and then the eye is capable of distinguishing only. So our eye is only capable of distinguish 30 gray level in the black and white image, but in the satellite image there are 256 minimum gray level appears. So that's why we cannot distinguish all this. So in the frequency distribution, we can identify different distribution of satellite DN values. So it is also sometimes asked the histogram and distributions. So in these areas, this is the previous satellite image, and it is distributed equally 10 to 150. So their frequency distribution is different, and this frequency distribution is different. So the based on the satellite image, the histogram uh, graph are different, and based on their DN values and based on their features also. If the features are different, then the DN values are different, then the histogram also different. So different kind of terrain sometimes produce constant histogram. Both images are of landscape and other bright area of the salt flats, dark areas, lava, and some common then surface with intermediate distal numbers. The histogram has two peaks and is said to be binomial, bimodal. Image also from the NDs has simple probability density functions, which gives the nearly symmetrical histogram. So the density of plot of individual pixel is a measure of where the peak is in the one-dimensional histogram on sites and highly correlated data. or classes of surface material that have similar appearance on image of the two bands plot near the straight line and the two-dimensional histogram. Poorly correlated data shows a shapeless cloud of the point in which the overall four coordinate system variable vegetable surface are like bare rocks and soil or water. These are appear. So there are three statistics are there, that is the mode, median and mean in the histogram of symmetry and skew distributions. The mode is the value that occurs mostly frequently in a distribution. So if the frequently one thing is occur, then that is the mode with the highest point on the curve. It is common, however, to encounter more than one mode is remote sensing data sets. Then the median is the value midway in the frequency distributions. This is the mean median. Is the median. So one half of the half below the distribution. Then the mean is the arithmetic average. So this is the mean, the arithmetic average of this brightness value observation divided by the number of observations. So these are the some statistical calculation are there, mean in the form of mean median mode. Then next class will be the georeferencing techniques. So we'll look this in next class. What is the georeference and how much georeference is useful for our remote sensing. So in these classes, generally some questions are asked like what is the different type of scanners are there, then across track scanner, then along track scanner, then histogram equal histogram, different histogram techniques are there. So and different resolution type, what is the different resolution like spatial, spectral, radiometric and temporal resolutions. Then different techniques of fusion techniques and some key stages of digital image processing, color image processing. So this is the also asked what is the different key stages of digital image processing. And the active sensor and passive sensor. So these are some important topic. Then spectral resolutions, radiometric resolution. This is the one short question and maybe asked, that is the instantaneous field of view. What is the instantaneous field of view? Then these are the some. Then the radiometric resolution. What is the radiometric resolution for 4-bit or 6-bit? That might be possible to ask in the exam. So these are the important topic which can be asked in the exam. Okay. So the today class is this is the today's class. So if any queries regarding this, we can ask. Amit Kumar, is it audible to you?
Yes, sir.
Okay, then any question or any queries?
सर
Because
मैंने थोड़ा लेट ज्वाइन किया
okay,
था कि
No, no,
ऑफिस
sir,
से
no,
आने
sir.
में, उसके बाद मैं कनेक्ट भी नहीं हो रहा था.
okay.
Sir, please share the slides.
हाँ, मैं अभी स्लाइड आपको भेज दूंगा,
Yes, sir.
इसको देख लेना थोड़ा.
Yes, sir.
सर वो
ओके.
पिछली स्लाइड भी कुछ आई नहीं सर.
हाँ,
जो पिछली स्लाइड
और
है वो भी शेयर.
अपने हाँ प्रीवियस स्लाइड जो जितना हुआ है उसको भी मैं
जी
भेज दूंगा, तो उसको उसको देख लेना. और कल थोड़ा सा जीआईएस का जो प्रैक्टिकल क्लासेस बेसिक बेसिक जीआईएस का है हुआ था, जो प्रीवियसली एक्सपीरियंस पर्सन है उनके लिए नहीं है, क्योंकि तो उनको तो बेसिक पता होगा। जो न्यूली एनरोल हुए हैं जिनको तो बेसिक सॉफ्टवेयर के बारे में पता नहीं है, तो उसको एक दिन क्लास में हम डिस्कस कर लेंगे कि बेसिक ऑपरेशंस, डिफरेंट वेक्टर डाटा, raster डाटा, डिफरेंट एप्लीकेशंस आर देयर। बिकॉज आपका प्रैक्टिकल होगा या नहीं पता नहीं, फिर भी हम थोड़ा ऑनलाइन क्लास करके थोड़ा सा बेसिक प्रैक्टिकल क्लास कर लेंगे उसके लास्ट क्लास में, तो आपको थोड़ा आइडिया भी हो जाएगा और आपका जो बेसिक थ्योरी कंप्लीट होने से आपको पता ही चल जाएगा सब चीज़ में। और बात है कि रिमोट सेंसिंग का जो प्रैक्टिकल है थोड़ा डिफ़िकल्ट होता है, क्योंकि उसमें थोड़ा बेसिक्स फिजिक्स और बेसिक स्टैटिस्टिकल एनालिसिस होता है। सो इट इज़ बेस्ड ऑन सम रिमोट सेंसिंग टेक्निक एंड, तो इसमें भी देख लेंगे क्या है। और आपका जो सिलेबस में है जो कुछ डिफरेंट प्रैक्टिकल जो है उसको भी देख लेंगे। तो प्रैक्टिकल का कुछ अलग का क्लास होता है या ये इसमें ही है? अभी तो इसमें जो शेड्यूल है उसमें तो प्रैक्टिकल का कुछ लिखा नहीं है।
हाँ सर, यही पता करना था कि प्रैक्टिकल हमारे मतलब सॉफ्टवेयर को सिखाएंगे कि ऐसे ही
हाँ वही
बस
तो,
वो भी
ऑनलाइन
हो जाए।
प्रैक्टिकल नहीं होगा ना फिर। उनका क्या है मुझे पता नहीं, अभी तक तो दिया नहीं है शेड्यूल में कि प्रैक्टिकल अभी जो रीजनल सेंटर है इसमें जाके सीखना है या ऑनलाइन क्लास के लिए अलग सा शेड्यूल बनाया जाएगा। तो आप थोड़ा कंफर्म करके आप इंस्टीट्यूट से पूछ लीजिए कि क्या होगा, क्योंकि आपका एक्चुअली ये क्लास बेस्ड ऑन प्रैक्टिकल, तो प्रैक्टिकल
यस
के
सर।
लिए ये क्लास आपने चूज किया है। तो थियरी तो ठीक है बट प्रैक्टिकल बहुत इम्पोर्टेंट है। और डाटा अवेलेबल भी होना चाहिए कि सब डाटा तो सब चीज़ में अवेलेबल नहीं होगा।
यस
फिर
सर।
भी मैं कुछ बेसिक डाटा जो दे दूंगा जो प्रैक्टिस के लिए है होगा। तो आप मुझे अभी चार्ट में लिख दीजिए जो जो प्रीवियसली जीआईएस फील्ड में काम नहीं किए हैं। तो थोड़ा चार्ट में आप अगर कोई है तो बता दीजिएगा। आप जितने भी हैं अभी सब जीआईएस पे काम कर चुके हैं ना?
यस सर,
अमित
मैं
कुमार,
आर्कजीएस पे कर रहा हूँ सर।
बलवंतर सिंह, आप आरजीएस में कर चुके हैं ना?
हाँ, करंटली वर्क करता हूँ मैं सर, बीच बीच में हफ्ते में एक दो बार यूज कर लेता हूँ।
अच्छा, आपका एप्लीकेशन क्या है, मतलब कौन से चीज़ पे काम करते हैं?
मैं सर डिफेंस रिसर्च में हूँ सर।
डिफेंस?
हाँ जी, डिफेंस रिसर्च में हूँ।
अच्छा, डीआरडीओ, डीआरडीओ में
हाँ जी, हाँ जी।
ना एनटीआरओ में?
नहीं, डीआरडीओ भी नहीं है सर, एनटीआरओ भी नहीं है, बट को लिंक्ड विद बोथ दिस एनटीआरओ, एनआरएससी एंड डीआरडीओ।
हाँ, मैं भी एक एनआरसी में ट्रेनिंग किया था, तो एनटीआरओ के कुछ साइंटिस्ट भी थे वहाँ पे।
जी जी सर।
तो बेसिकली वो एनटीआरओ में हम हमारे क्या है, वो तो राडर टेक्नोलॉजी एंड माइक्रोवेव में ज़्यादा काम करते हैं, क्योंकि उनका ज़्यादा एप्लीकेशन वहाँ पे है। तो ठीक है, अभी माइक्रोवेव का तो सॉफ्टवेयर अभी इजीली नहीं मिलता है, और उसका सेटेलाइट डाटा भी बहुत लार्ज वॉल्यूम में है। फिर भी
जी।
देखते हैं अगर कुछ होता है। और मैं सोच रहा था कि लास्ट क्लास एक गूगल अर्थ इंजन में काम कर देते हैं, जिसमें
हाँ
आपको
सर,
डाटा फ्रीली अवेलेबल मिल जाएगा।
इंजन वर्क पे पूरा काम करें
हाँ,
सर।
तो उसका लास्ट क्लास तो जो करेंगे थोड़ा सा गूगल अर्थ इंजन में कर देते हैं, जिसमें आपको फ्रीली डाटा अवेलेबल भी हो जाएगा और उस पर
जी
आप एनालिसिस भी कर सकते हैं। तो अभी
जी
जो
जी।
रिसेंट ट्रेंड में है, अगर आपके पास सॉफ्टवेयर नहीं है तो बेसिक चीज़ आप कर सकते हैं। तो
ठीक।
अभी मनीष कुमार जी तो वो तो जीएस फील्ड में है शायद। एंड ठीक है, तो नेक्स्ट देते हैं। अब बेसिक थ्योरी क्लास ख़त्म होने के बाद अभी अगर प्रैक्टिकल होता है तो ठीक है, अलग से कोई ले रहा है, नहीं तो हम कुछ थोड़ा सा बेसिक चीज़ उसमें भी दिखा लेंगे। तो आप एक चीज़ चार्ट में आप सेंड कर दीजिए जो भी है अभी। तो अगर कोई जीएस का एक्सपीरियंस है तो किस फील्ड में काम कर रहे हैं, तो उसके हिसाब से थोड़ा सा एप्लीकेशन हम देख लेंगे और उसमें से कुछ क्या प्रॉब्लम आ रहा है और उसमें से क्या और ज़्यादा हेल्पफुल हो सकता है। अभी ये रिमोट सेंसिंग टेक्नोलॉजी डिफरेंट डिफरेंट जो न्यू आ रहा है और उसमें क्या प्रॉब्लम आ रहा है, उसको सॉल्यूशन कैसे कर सकते हैं। आप थोड़ा सा भेज दीजिए कि आपका जो सपोज जेस फील्ड में काम कर रहे हैं, सपोज वाटरशेड फॉरेस्ट्री और एनी डिफरेंट एप्लीकेशन, तो हम देखते हैं उसमें से क्या आपका आपके लिए कुछ एडिशन आ सकता है। ओके
ओके।
ओके ओके, थैंक यू। देन we'll conclude this season. Thank you. Thank you, Amit.
थैंक यू
Thank
सर।
you, Mani. Thank you. Thank you, Balminta. Thank you, and Andrews. Samal Raj is also there.
Thank you, sir.
Thank you.